So, Art, welcome, and we look forward to your presentation. Thank you.
This is not a research paper. I'm going to mull over some of the characteristics of the way people handle big data, and also consider some of the aspects of smart city research. And I have a certain amount of time, about 20 minutes, to talk about some of these considerations. I'd like to mention first that I'm perhaps the oldest person in this room, and my academic life has been very long, and when I started out many, many years ago, we did talk about scientific analysis and worked with small samples like 6 or 4, non-parametric statistics. Our memories were small. I used a slide rule at one time and kind of pen and ink for many other kinds of activities. Today, of course, everything is turned around. Big data, not much theory, by the way. Advanced visualization, very prominent and popular. Much empiricism, but not the way we did it those days. There are sophisticated models, and there are some people who now think that there is no need for models. We've got the whole sample, we have the population. So things have changed. We can put away as much material as we want and get as much material as we want through the cloud, and so on. I noted from a source that in 1 second, each and every second now, there are these things that happen in the world in 1 second. And if there are over 2.5 million emails sent in 1 second, just do a little multiplication and you can see just how much information is available to all sorts of people. And notice I have 30 terabytes of data are created each second. And of course that number and all these numbers are increasing per second. So we have an expanding universe of data. And there are all sorts of now ways in which to handle the big data. And there are bigger and better networks, and they're expanding. It's kind of like our universe is expanding at a very rapid rate. And actually, it's very attractive to many people, especially young people interested in trying to figure out ways to delve into big data and either pull things out or create better programs to use one or more programs to introduce one set of data to another set of data. So the challenges are many in this field: capture, storage, analysis, data management, and the literature is really filled with this kind of thing now. And if you look for the successes in big data, for many of us in the academic world, we're still searching for the successes, but in the business world, it's quite the opposite. The successes are coming in very, very rapidly, and especially since the privacy rules have not yet been established on a permanent basis, there are all sorts of possibilities that especially businesses can delve into. And where have they been successful? Mainly in the fields that I've mentioned here: health, selling things, drugs and diseases. If I had more time, I'd read you a little story about eBay, the company eBay, that creates thousands, millions of observations per minute from all of their auctions that they have. And They talk about them, and they say that that's responsible for their great success. But it's also it's responsible for not their failures necessarily, but for many of the things that stimulate them to delve more deeply into this field, because they find that relatively few people can deal with big data. A lot of us perhaps think it's an easy thing. You get a set of data. They find that the data that comes in are not necessarily at the same scale as they would possibly want, and that different offices of eBay in different parts of the world receive the data differently, and they find it very difficult to integrate the data. And they find the number of people who can handle big data to be relatively few. So it's an issue among even those who are finding great success with big data. And so I've mentioned a number of things where they have been successful: more effective marketing, better customer service, comparative advantage, and so forth. Many, many successes. And there are many, many places to store the big data, and they, of course, have access to the software that leads you to the cloud and so on. Many data processing systems have been invented. You may have heard of Hadoop if you have dealt with big data, and you know that that's only one of the kinds of software libraries that allow you to distribute the data to many, many computers at one time. You can process great hordes of data. So there's no shortage of ways in which you can handle the data. It doesn't mean that you know what you're doing, but there you are. You can handle the data. That is, you could get them into systems. And networks become, you can deal with all sorts of network software. Here are some of the network analytic schemes, and this is just one list. Rumor and viral marketing, resilience and robustness. These are ways in which you can, quote, handle the big data. So the issue among academics is this: as theory and applications become more intertwined, thorough knowledge of each becomes even more crucial. And just a few minutes ago, I was talking with someone who was saying that there had to be someone who knew something about economics, and there had to be somebody who knew something about processing of big data. And one had to teach the other in order for something to happen. And that's not really that easy. I mean, you have to have an economist who knows something about economics, and you have to have somebody who knows something about computer science to handle the others. How they get together may be questionable. So there are problems and challenges at every stage of big data usage: the problem identification, data set gathering, compatibility, privacy, scale, data management, visualization. There's so many different things: operations and analytics, interpretations, uncertainties, probabilities, identification of new problems. And then I say, but that's the business world. Now let's step over into the academic world. And they're not the same. The business world, their general bottom line is profit, and their general operations move in that direction nearly all the time. The academics were accustomed to working in small groups. Many of us still do work either individually or with a small group. You really can't handle big data problems in the academic world with one or two people. You need a team, and there are very, very few teams of big data users out there right now. So there are real difficulties in creating the problems that we're used to in the academic world to work them into a big data kind of opportunity. But it doesn't mean that people aren't trying. It means that there are relatively few places where people are successfully in academia finding a way to work with big data. So I write, just touching the surface of improving quality of outcomes and efficiency. So I would say the academic world is on the ground floor, maybe even in the basement, before they get going in this field. Now let's switch over to the smart city movement. And the point that I'm making here is that ICT combined with traditional urban infrastructures have to be coordinated to work in this field. So that when you look at a diagram like this, and you look at the different components as we have here, of what the smart city analysts are busy doing, each one of these items, if you can read them, is wed to big data. So that the smart city movement, I would say, is not quite academic yet, because these kinds of things are really related to the handling of big data, of which very few academics are truly able to do. Just to mention one of the kinds of things that people can move to easily in academia, and that is to go to 3D city models, which you can now make huge models of landscapes and at a different scale, buildings in cities and so on. And what we can do is we can send out that information to many different people, organizations, and so on, and use the cloud service in the process. And it's now possible relatively easily is to take a 2D information unit and superimpose it on the 3D so that we can see zoning and utilities and things like that, which could be very helpful in the solution to the kinds of problems that academics might be faced with. And there are many, many things that you can possibly do in that field as well. Perhaps the biggest organization in the, what you might call the smart city academic area is at University College London, Mike Batty, who's been mentioned several times already here, who has a fairly large unit of people who are working with these various kinds of issues that we face in if we want to address something called a smart city. I've written out here actually 4 pages of what I call smart city analytics. These are the kinds of problems that Batty and others are working on. Delivering social services more efficiently, that turns out to be an academic problem. Intervention to those at risk of poor health outcomes. Causes of poor air quality, identifying those. So there's no shortage of challenges that we in this field are faced with. And I think it's time for us to get ourselves really organized with experts in a number of fields where we have our own individual responsibilities spelled out beforehand so that we know where we're going in these areas. More kinds of issues, predict bridge problems, improve utility inspections. Many of these go on and on. My own interests are in spatial studies. And in fact, that is one of the places where I think that we can make a very big contribution. Because many of spatial studies sort of lend themselves to huge amounts of georeferenced data. So that we have things that you see there on the left, visualization, digital mapping, data mining, which I don't approve of, dynamic mapping, data analysis, monitoring, and so on. Many, many different kinds of big data opportunities in the spatial studies. I say that our role in that area is in identifying or finding causal relationships between and among relevant variables in a spatial setting. And the moment I say finding causal relationships, that begs the question of rigor. And that begs the question of scientific usage. And that means that the scientific method is not dead. It's going quickly, but it's not dead yet. And in fact, if we want to come up with new ideas and better ideas about the city and how it functions and how smart cities can be created, I think it would be a very good idea is to follow a theoretical point of view and then get into the big data and to kind of solve the problem if you know a little bit about statistics, because in my judgment, sampling is not dead, and many of the other kinds of things that are part of the statistical literature are certainly still alive. So there are many opportunities, and there are many types of georeferenced big data. I list a number of these things here. And then pointing out there's actually two major issues that are disregarded in the business world, and but it doesn't matter that much that they disregard what you might call map scale. You know, if you get 2 or 3 million observations from Kansas and only 50,000 from Nevada, it doesn't really matter very much from their point of view. But it does matter, and it does matter at what scale you're operating. Are we talking about towns? Are we talking about huge cities? Are we talking about individuals, and so on? And then I particularly emphasize, and this is where my work comes in, to what I call the spatial autocorrelation problem, which to me is the huge urban problem that the people in our field of smart cities or attempting to work in smart cities have to be very concerned about. Because if you think about a couple of 100 million observations in some relatively small area, let's say, let's just take the Netherlands, and say that we have hundreds of millions of observations and we're working in a spatial analysis, the chances of nearby observations being autocorrelated is very, very high, close to 1. And that means that you are seeing redundancy in the data. That means you're measuring the same thing time and time and time again. And the question is that legitimate from a scientific point of view? And it is not. So you have to do something about that. And spatial autocorrelation problems, if you're aware of them, and recognize how they may affect your results, you have to deal with that. And of course, there are other things, other kinds of problems to worry about as well. And I mentioned these other problems that are associated with it: data mining, redundancy in data, heterogeneity, sampling scale. All of these are what I call aspects of the spatial autocorrelation problem that has to be taken into account if people are going to deal with georeferenced data. No way out. And then a discussion of sample size and the difficulties that we are faced with such an issue. In order to have ourselves be free of redundancy and spatial autocorrelation, we have to begin thinking about sampling. And there is quite a bit of sampling being done in big data analysis, but I think there's several very important issues in how to do that kind of sampling. And especially since we have the problem of spatial autocorrelation to work with. We don't want spatial autocorrelations equal to 1. Okay, so what we face now among many of our students is that they're very excited about all the opportunities with big data, and they're spending more time on trying to handle big data, capture it, store it, work with it in some way, and they're of the belief that more data are better. Also, other erroneous assumptions: correlation indicates causation, That's a difficult one. Also, scientific sounding solutions to hopelessly imprecise questions. These are assumptions that people are making. Impeccable source that I have, when in fact, when they check that impeccable source against another impeccable source, one is more impeccable than the other. So good software is important too. Illustrations will take care of it. If you can't do it one way, at least come up with some really good illustrations. That'll get you through some of the problem. Understanding of spatial data. I think it's important for people who are working with spatial data to take a course in, you might call it spatial statistics. The scientific future, understand where we're going. And there's the assumption that accessibility makes it ethical. And now we're reading in the newspaper nearly every day about some breach of ethics using big data. It's a very serious issue. And I don't know how far we can go in gathering data where we are not faced with privacy considerations, among others. And then there's the view by some that there's no need to sample since we have it all. And it's coming in faster than we can possibly handle it anyway. So one of the assumptions is that this is a replacement for scientific inquiry. We don't have to take that rigid probability course, or we don't have to study statistics because we've got it all here. Big mistake. Okay. So some conclusions. Meaningful science, questions linked to the literature. I think it would be very helpful if we continued in the tradition, and many of us are, of course, continuing that tradition of building on what has been created, understood, checked, rechecked from the past, and linking our work to very good work of the past. Science requires verification. We must plan ahead. We must consider the appropriate geographic scale if we're going to deal with georeferenced data. Teams, as I said before, teams of experts adds efficiency. If you can come up with a good team where each understands each other and can communicate and gets in touch with one another on a regular basis, we're better off. Management efficiency is needed, and if you read even into the business world, you'll find that they are struggling with management efficiency and trying to handle all the information that's coming in. Checklists are helpful. Differentiate excitement from usefulness. I think that would be a good guide to. So more may or it may not mean better. Thank you.
Well, thank you, Art, for a very clear presentation that really gives a wonderful overview of the challenges with using big data in spatial context. And the good thing is you've also been immaculate in sticking to the time that we had been prescribed for this. So there is time for a couple of questions, and so I open the floor for discussion. If anyone wants to start it off? Yeah. We've got one. Okay.
Mr. Geddes, could you please repeat why it is important not to overestimate the value of populations compared to samples?
Could you repeat your question? I'm sorry. My hearing is, especially with this thing in it, is.
Could you please summarize why it's important to not to overestimate the value of populations compared to samples?
Why not? First of all, most research is based on logic. We follow from one step to the next, usually pre-planned, knowing how many observations are needed in order to test our hypothesis. Now, if our hypotheses, of course, become more complicated because there are opportunities to make them more complicated, we must be aware of that. And so I think it's your goal before you actually begin the data gathering and so on, you'll find that a lot of big data sets that are out there are really not very reliable. I mean, this is in the business world so much, but if you may have heard about the flu case. Anybody know about the flu case? Yeah. It was seen by a number of researchers that there was a lot of Twitter and all sorts of Facebook commentaries, you might say, on flu about 10 days before the flu epidemic hit. So they were saying, here we have the solution to the flu question. We just watch the social media, and when there's some activity, we'll know what's coming. Well, so then the second flu epidemic came along, and people got excited again about that and so on, and it was completely wrong. There's a whole story of why it was wrong and so on like that. What I'm really saying in a long way is that our logic, good sense, and knowledge play a very big role in all of this.
Yeah, I'll just,
I was wondering, you mentioned several times the value of working in teams of scientists where people have different expertises and can teach each other, but you also emphasized that business is already quite successful in big data. Of course, their processes and things are different, but in the teams, do you think there's also a role for people from the businesses?
Do I think there's a role for
that they can be part of the team, so that they can also be one of the teachers and the learners in the scientific community?
I mean, if you're wise in your research project, it would be a very good idea to have someone who has some experience in this area. You can teach them about what really is important. They can teach you how to get the material and how to store it and manage it, perhaps. I think there's a role. I think it would be very helpful if businesses work together with academics on these issues, as long as you don't get into what it is that they're after necessarily as a bottom line versus what you're after.
Yeah, thank you.
There's time for one more final question, perhaps? Anyone? Manfred, you'd like to ask a question?
I would like to compliment this in this respect. Of course, in business, especially Google in the area of artificial intelligence, university professors are building up huge labs in industry to deal with this issue as well. But they have different objectives in mind, different goals. Of course, in business, you would like to keep the secrets for yourself. But in science, we have open-minded, and we have to be careful so we understand the fundamentals behind the algorithm, because otherwise you're being lost. And this is in addition what you mentioned.
That's a very good point.
Okay, well, thank you again, Art, for your presentation and for that we started kick off some nice discussion here, which will continue later.